We are all well aware of the universe's infinite potential to create, destroy, and forge everything we could possibly understand, and more. A sheer mass of raw existence inhabiting the most basic to the most complex forms of existence that we know of, and it has no plan on stopping soon. It will truly forever remain humanity's greatest mystery, and not 1 second in the universe is the same. All we can do is figure out as much as possible before our end. But what is the universe's end? Does it even have one? How do we even get these assumptions? Just as the universe theoretically started after a Big Bang, astronomers are now attempting to study this expansion to predict how the universe will ultimately end. The rate of this expansion may eventually tear the universe apart, forcing it to end in a big rip. Alternatively, the universe could shrink, decrease, or decay, effectively reversing the Big Bang and destroying the universe in a big crunch. There's a lot more bigs in this one than the previous video, I've got to be honest. As the cosmos expands, never-endingly, and stars and galaxies grow dim, and everything slowly becomes colder and more isolated into a big freeze, could the dark energy that's accelerating the expansion of the universe eventually rend apart space-time? Would it be possible for our world and the rest of the universe to one day just cease to exist without warning? Well, I'll discuss the most plausible ones for now. Until around 5 billion years ago, the universe's growth was slow due to its strong gravitational pull from everything being so close together. More recently, this expansion has increased, with many attributing it to the effects of dark energy. But for a big rip to occur, dark energy must win its battle against the four forces of attraction to such a point that it can rip apart individual atoms. It's almost like a constant war of forces versus energy. One may hold its ground, but the other is unrelenting in its attacks. Last year, Marcello Disconzi, assistant professor of mathematics at Vanderbilt University in Tennessee, in collaboration with physics professor Thomas Kephart and Robert Scherer, devised a new mathematical model for the Big Rip. This model just implies that the expansion of the universe will eventually become infinite. Previous models largely ignored what I like to call cosmic viscosity. But in Marcello's hypotheses, it is the viscosity of the universe that drives its violent destruction. His theory was based on proposals made by the French mathematician André Lichnerowicz, I think that's right, Lichnerowicz? I hope so, in the 50s. Or if, instead of expanding forever, the matter in the universe reaches a point until it starts to decrease expansion over time, it could cause gravity to become the dominant force instead of dark matter, cause stars, planets, and entire galaxies to collide into each other, and the universe would, well, for all intents and purposes, collapse in on itself. Put simply, if the expansion of the universe slows to a crawl, and the Big Bang happens in reverse, everything will implode back into a singularity. But of course, it being put back into this loop, it'd most likely just burst out again. So more of a universal loop rather than its end. Researchers in Denmark recently claimed to have proved that this process, known as phase transition, could already be occurring in our universe. This transition is said to be similar to what happens when water turns to steam. For example, according to the Higgs theory, it occurs 1/10 of a billion of a second after the Big Bang, causing a shift in the fabric of space-time. It basically says that empty space becomes filled with an invisible substance known as the Higgs field. Some astronomers believe a sphere of this field could appear at any state at any point in the universe. The researchers' equations suggest that this sort of universe bubble could then expand at the speed of light, entering all space and turning the Higgs field from the state it is in now into a new one. The rules of quantum mechanics also suggest random particles can momentarily pop out of a vacuum, something that is seen regularly in particle physics experiments. If you think this sounds like the least plausible theory, you'd be very correct. Still plausible. The final, most plausible theory states that the universe could end in something similar to a universe-style big freeze, and also somewhat conversely called heat death. I don't like the name. It's a bit too evil, This scenario is believed to be the most likely according to what we already know about physics and the current universe. This term comes from the theory that in the universe and other isolated systems, entropy will increase until it reaches a maximum value. Entropy is basically like a measurement of how much the atoms in a substance are free to spread out and move around and arrange themselves in random ways. For instance, when a substance changes from a solid to a liquid, like, ice to water, the atoms in the substance get more freedom to move around. So, ice has a lower entropy and water has a higher entropy. Once entropy reaches its maximum, those atoms have way too much free space. This means that there would be no more interactions between things for usable energy or heat or, anything to exist, and the universe would die from lack of interaction. In other words, mechanical motion within the universe will cease. And it makes sense why it's called heat death, but it just sounds really big freeze. I like this big stuff. I hated it in the last episode, but it's really growing on me now. And during this big freeze, the universe would, in theory, become so vast that the supplies of gas would be spread so thin that no new stars can form. So, under that model, time becomes an endless void in which nothing ever happens, and there is little to no energy left in the universe. It'll all end there. But, considering how history always flings itself incorrectly, like a bad game of Chinese whispers, it'll all end eventually, so why get so hung up on it? I'm implying stay positive, but thank you for watching.